Alright, I've already put a point on the paper for us here. Let's call that one point P, so we can talk about it. And we'll take the compass and use it for the center of a circle and swing it around and see what we get here. There we go. There's our circle with point P as its center. And we'll draw a pair of diagonals, diameters I should say. Diameters are chords that run through the center of the circle and go all the way across. A radius would be a line segment from the center of the circle to the circle itself. And there's that one. And let's do one this way. So we have two of them. I think I may have missed the center just a little bit. There we go. There we go. That'll do. That'll do. A central angle is an angle that has its vertex at the center, and it cuts off a part of the circle, which would be called an arc. And the Babylonians had a numbering system based on the number 60, and they cut the circle up into 360 parts. So let's just call this one here point A and point B. And this then would be arc AB. And its measure would be the same as its central angle. So we'll call that x degrees in there. The measure of arc AB then would be x degrees in this drawing. And on the other side over here, let's just go on around the circle, shall we? All around the other side. Let's come over here. We'll just call this one point C, point D, and point E, and point F. So if I wanted to talk about arc ABD or ACD, that would be the same. That would be half a circle. And since we have the circle cut up into 360 degrees, the measure of arc ACD would be half the circle, or 180 degrees. And this one in here, I don't know what that is. Let's just say we come across here this way, and we'll call this one over here arc AFE. Let's say that's y degrees. We don't know what it is, but it's a number. There we are. I guess there's really no confusion here because it's less than half the circle, so I could have said simply arc AE without having the F involved in it, but that's okay. On the other side of this, I've got an arc from B around C to D, and the measure of arc BD, let's call that Z degrees. Now this will be Z degrees over here. So, what do you think, guys? Do you think that angle DPB would equaling Z degrees and angle APE equaling Y degrees? You think they might be equal to each other? It's definitely possible, don't you think? We have arc ACD, which is this side, equal to 180, and I have a feeling that arc BFE is also 180. Measure of arc BFE is equal to 180 also. Fascinating. Now, since arcs are measured by their central angle, I can think that if I take x and y and add it together, I'm going to have BFE. X plus y would equal 180 degrees. And going the other way, x plus z, we're going to be arc ACD, x plus z, would also equal 180 degrees. If I use the symmetric property and flip this around, I get 180 degrees is equal to x plus z. And if I use the transitivity property, where this one here is equal to 180 and 180 is equal to x plus z, I can say that x plus y must equal x plus z by transitivity. And I notice that I have x's on both sides of this, and if I subtract x degrees from both sides, using the subtraction property of equality, I end up with y degrees must equal z degrees, which means that this angle here must equal this angle here. And when you have two angles formed by intersecting line, they're called vertical angles. And what we have here is an outline of a proof that vertical angles are congruent. And we thank our Babylonian friends for cutting it up into 360 degrees and giving us some numbers we can talk about. The central angles are equal to the arcs, and the vertical angles are equal.